Hey, are you DIY? Well, hell, you're my kind of people. Let's build something. All right, so here's what we got. DIY 12-volt battery with some awesome cells, LEV 60-F, 200 amps, continuous, about 600 for 10 seconds, right? So, what do we need? We need to add a BMS. This bad boy right here. Well, I mean, you could add any, but this one is pretty cool because it does 200 amps. And it also does about 600 amps, for about 10 seconds. It's small, it's light, it's cheap. So we gotta somehow install that in there. Now, of course, you could use bubble gum and a couple of paper clips and some socks or something and attach it, in here somewhere, run a bunch of cables, do all that nonsense. But let's design a board that we can put on top here, and then you just screw it on, put one connector, and then you're ready to go. And this thing will live up here. Okay, to the drawing board. I hope you're up for the challenge. By the way, this video is sponsored by PCBWay. More on them later. For now, let's start designing the custom part. So here's our setup. Let's do the outline. And of course, we're just gonna copy it from the other one that we've already drawn. Boom, so there it is. This is the basic outline of our project, right? I went and measured this BMS thing, and then I just measured this and that and that, and then I just drew it in there, and then that has a little hole in there. And you're gonna see why that has a little hole just in a little bit. So now what we do is we start adding multi-layer. So these are the holes, right? So we need to draw these holes right here, where are the M5 bolts that go in here, right? And this is basically the input and then the output of this switch. This is a BMS, right, unit, and it's just basically a switch. It's got MOSFETs in here. It lets the current from one side to the other. All I have to do is measure these holes, the distance here, right, and then the size of the hole, and then you have to draw those in here. And that's what I've done here. This is the BMS, and I've done that. Add solder mask. There it is. The top and the bottom. Here's the bottom. This is the portion of the trace or the layer that is going to be exposed, not painted. The rest of the stuff is going to be painted. Here is the other side. One is the bottom, one is the top, right? So then here are the other two that I transfer from the original board. The original board is the one that's on top of the cells, the ones that we just saw on the table there, right? So then what we can do is also, by the way, I want to make sure that you guys know how to get, because this is going to be an open source project, right? So you'll be able to download this file that we're going to design here, and then you can go and buy all the components by yourself. So here's the link of the most important component, which is the BMS unit that that we're going to install in here. So if you want to go and buy it, here's an AliExpress link so that you can go and buy it. Also, boom, I just added all this stuff. Now let's look at what's going on here. So these round things that I put in, this are going to be our terminals, input and output, right? So negative and positive. And I wanted to make them very clear to the end user. This is where the output is at. Not here, because someone might make the mistake and try to put lugs in here. But this is the input to this BMS board, right? And so not here. And I used to have like positive and negative down here, but then I was like, nope, let's take those off in small letters. Now you can see that this is the B minus and this is the B plus, battery positive, but battery negative, right? But in giant, with the circle in here, this is the output. Output is negative, positive. Also, for people who want to know what's going on more in the battery, some people have asked this in the past, so I'm just starting to put this in every one of our projects. They want to see the electrical schematic. They want to know, well, how is this connected? How is this battery put together? Where are the cells? How are these little IDC, male connectors that you're putting on these batteries? What are those pins? Well, here are the pins. I have them labeled B minus, C2, C are center taps of these batteries, right? And then B plus. So you can exactly know where these pins are going. How are they connected? And this is the schematic of the battery. And that's what you're connected in here. And then here is just gonna go into the BMS, right? 12 volts, 200 amps, continuous. That's the BMS that's in there. Also, I have, let's delete that in here. Just some typical things, information that might be useful when you're doing this project. For use with these batteries here, the LEV60Fs, and this is a URL, so you can click on this or type this in on a on a browser, and then you can see where they're at, and you can then get more info on the cells, right? 12 volt, which is a 4 cells in series, and then lithium iron phosphate. Capacity 24 amp hours, continuous power 180 amps, peak power for 10 seconds, 600 amps. Just pretty broad, basic information. Then what do we do here? So let's look at, this is bottom. Let's look at the top layer. Bottom layer? Yeah, bottom layer, right? So this is the bottom layer. This is the copper. So what is happening here is we're connecting this B minus, the battery negative. We're connecting this through this pad right here to the B minus of the BMS unit. So this is the input of the BMS. So the energy is flowing from here to there. So you're gonna see a hot spot here because this is what's gonna see the brunt of the energy of the current, right? And then from here, the P, then that's the load, that's the exit point, that's gonna go over here. Very simple. You see that? It just goes in here, and then the energy goes out here. So this is connected to that through the BMS. And then on this side, it's even simpler. Just the battery positive is just going to the positive terminal over here. And so this pad right here just connects the battery terminal into this board terminal. So then that's the lower copper pad, right? On the upper pad, this is the one on top layer, it is the same thing. On the positive, it just connects the same thing. On this one, it just connects that, and this one is the same thing. So it just mirrors the bottom. But then we have these extra little traces that go here. And all this is just connecting this IDC 16-pin connector that it's very common in all my builds, right? To what it's happening.
Bixby voice privacy content.
Okay, I don't know what that is. But what that is doing is, what in the world is this? Okay, what that's doing right here is just connecting this pin right here into this other pin. And this pin is gonna be a screw terminal connector, because eventually we might sell these kind of already put together, and that means that you will be able to put it together without having solder. For some reason, people think soldering is hard. I mean, you need some specialized equipment like a solder and iron and stuff like that. But, it's some people don't want to do it, but they still want to use this battery, this thing. We're going to make it available. There's levels of DIY, and I want to help as many people kind of build their own batteries. And, and so there's all the different levels, right? From the ones that want to do everything themselves and want to learn as much as possible, to the ones where like, can I just buy all the parts and then just bolt them together and some light assembly, and then we can get it used. Yeah, I'm not an enemy of that. I'm not against that, and so that's why I'm offering this right here. So that's why we're gonna make this connector into this connector, because this connector is really, really beginner friendly. It's gonna allow you to do solderless. And so these then are just gonna go into a wire that comes with the BMS right here, right? So then bottom is got the thing. The document has got nothing else. There we go. So this is a very simple board that we just designed here. This dimensions, the smaller the boards are, then the cheaper they are. Now, in this case, you want to make sure that you have enough of this width to carry that much current, right? And so in fact, I'm going to put it right here that I'm gonna put a small thing like this, copy, paste. Oh my God, this thing is terrible. These layers, that's what I always. So what I'm gonna put it here, I'm gonna put 2 ounce copper, right? So I recommend you make this board out of 2 ounce, because then when you download the file, you have the ability to choose whichever thickness of copper you want on theirs. But I recommend 2 ounce copper because then that gives you that much more capacity to carry. Remember, it's 200 amps that are gonna be going through this, right? So this is a size that I came up with and stuff. So now what you can do is just look at it in 3D, and that is what the board is gonna look like. This program is weird. It doesn't show you this cutout. There's no board in here. It should be like a hole, sort of like this one, but it's okay. I've learned to kind of ignore that. If you actually do the 2D, then it shows you a more accurate representation of what that's gonna look. See, here's a hole. And so those pads right here, by the way, this is exposed copper on this side, but on the bottom side is just those. And what we're gonna do is we're gonna put screws and nuts in there, and basically this just needs to be exposed to get the nut or the top of the screw, whichever way you install the thing. And then, but on this side, it needs to be 100% exposed, because then that makes full contact with this portion of the BMS, which is just a big, thick copper pad that they put on the BMS. And that will help you really transmit the power from in and out of the BMS, right? So that's why we have this here. So now let's order this at PCBWay, our sponsored. And just like that, bam! PCBWay is pretty fast. They make these, within a couple of days, and then they ship them. So within like 4 or 5 days, you have these in here, and now you can test them. So here's our battery, and the first thing that I want to do is I kind of just want to check to see the dimensions are correct. There we go. See, these I kind of made them big like that, so that you have some room to play. Now, what we're gonna use here is gonna be these standoffs. These are big M8 times 1.5 threaded, right, pitch threaded things in here. There we go. Just look at that. And then M8 bolts in here. So that's how we're gonna connect this board into this. Okay, so that makes sense. And then we're just gonna put some standoffs. Okay, let's populate this board. We'll put the connectors, we'll put the terminals, and then we'll put the BMS. Let's go to the other bench. Okay, so here's what we're gonna need. The 2 big 180 amp terminals, and then you're gonna need this green terminal connector here, and then the 16 pin IDC connector. Let's solder these in here. Okay, now that it's cool, it's time to install our BMS here. So we just put it in here, make sure this is clean and that is clean. Put the 4 screws that come with the BMS. These screws come in there. And the nuts also come in the BMS kit. Okay, let's go install it on the battery. Oh, one last thing. This is the cable. So it goes on here. Okay, these connectors are very interesting. You have to lower and open the little hole. You see that? So you have to do that to both before you can put the connectors in there. If you don't do that, then it's not gonna work. Then we stick the cable in there. Let's install this on the battery now. All right, so here's our battery. The first things we're gonna do is install these and tighten the standoffs. Then you install this unit in here. See, positive, negative, negative, positive, right there, right? Washer. Last thing is gonna be this little ribbon cable. It's just 2 connectors. Make sure the connectors are facing the same way, with the little keyway facing the same way. And there we go. Our battery is done. Now you have a 200 amp BMS. The output is right here. You charge it through here and you discharge it through here. Let's put a cable on there. I recommend making a cable like this that has a discharge connector, right? That they can do big, 200 amps, no problem. But then you could also put a smaller connector in the same cable so that you can then connect this to your charger, and then you put it there. Depending on how you're going to use this and your circuit and stuff, right? But this would be one way to charge them. Today, we're going to install this big cable just to discharge it. All right, and there it is. There's your battery. Now this battery has a BMS. Now let's check to make sure that the BMS is working. One quick easy way to do that is just with a multimeter. 13.17, so this is the same voltage. Usually when the BMS is off, you will see less voltage, right? Because it's just some leakage that's going there. Sometimes you will see 0, but a lot of times you'll see just some like 8 or 5 or 3 volts, just some small amount of voltage in there. Now sometimes this might be off, and this thing will recognize full voltage if this thing leaks too much voltage into there, right? And so the final way to test it is just to put a load in here, and if it powers a load, if it do, up to 200 amps, then that's fine. We have a working BMS. All right, so what is this battery good for? Well, anything that needs 12 volts, right? These are long-lasting cells. They last, I think, 5,000 cycles or something like that. These were used by BMW on 12-volt batteries, like under the hood batteries, right? And they had their own BMS and their own data system that would talk to the car and some stuff. These cells, I guess they didn't get used in that, and so now that's why they're available as raw cells. And so that's why we're making all this stuff to make this battery, right? These cells came to us just raw. And then all these other little things you are going to need to make a fully functioning battery like this, right? And of course, you can use this battery alone. This will start a car, no problem. It can put out about 600 amps for 10 seconds, right? Which is more than enough to start almost any car. But they're lighter and they last longer than typical lead acid. Now, this could be used for automotive use, for car audio stuff, because they can put quite a bit of power. You can use it like this alone, one single battery. You could put 2 of these batteries together and then just connect them in parallel. All you have to make sure is that the cells, the battery is about the same voltage before you connect them, or else you'll see big sparks and stuff, and you might melt stuff, and you might get this unit to go into protect if you are trying to connect like a fully charged battery into a fully discharged battery. So just make sure it's around the same voltage. You can connect this. Now, obviously, you could also connect a couple of these in series to make 24 volts, but if you're gonna do that, I would suggest you just build a 24 volt. We have all the same kits like this. We're just gonna be for 24 volts. So there you go. Thank you for following this project along. You can order all these parts by going to PCBWay.com. PCBWay is the sponsor of this video. They make your custom PCBs in as little as a few days, right? You upload the file, you can design your own PCBs, or you can use some of the ones that I've already designed, and you order them, and that's how you get these for super cheap. DIY will save you money because then you can order all this stuff straight from the source, and then you can build these batteries, right? This battery right here, as you see it on the open market, it's worth about $1,200. That's how much a BMW will charge you for this battery. Well, if you DIY this is only going to be like $380, something like that. So the savings are substantial when you do DIY projects like this, right? And so if you're looking for a battery that is very, very powerful and it's easy to build, you can go to PCBWay.com and order all the parts. Now, also, if you just don't want to fuss around and build this like this, we also have this battery available just the way you see it here at jack35.com, and then you could just order the battery, and it just works. It'll come assembled like this, pre-assembled like this by us, and then you can use this battery, right? So there you go, another battery project on the books. Thank you for following along. Thank you for watching these videos, and thank you for supporting and buying all this stuff and building your own batteries. I believe DIY, it's a very powerful thing, and it's the best way to learn to do things, right? And so I want to thank PCBWay for sponsoring this video. We'll see you guys on the next one. Bye. Oh, by the way, if you have HBO Max, make sure you watch Robert Downey's Dream Cars. I have an episode where I converted a VW bus into a fully electric car, and then we went and shot the episode and stuff, and we run around in the beach and stuff like that. So if you have HBO Max, my episode will be released, I think, mid-July, but you can go and watch the first and the second episode right now, and I think the second and third episodes will be released this week. Right, so today is the day that we do the red carpet and we see the first episode.
But I mean, also classic cars are a pain in the ass.